Okay, so very good evening to all of you. Now, today we will be discussing an advanced multivariate technique that is called factor analysis. Now, I'm sure that since there has already been a couple of days since this statistical data analysis workshop has been started, so I'm sure by now you all must be aware of different types of advanced statistical data analysis, which includes bivariate and then multivariate analysis. I think you all must have heard about regression, studied regression. I think in the previous lecture itself, maybe yesterday, regression was discussed with all of you. Regression is another multivariate technique, and factor analysis is also a multivariate technique, which we will be discussing today. Now, what is the basic difference between regression and factor? I will be taking you through that only, so that you all are able to understand that what exactly is the difference between.
We have to mute all the participants, and once we will take the question, and then we will unmute. So it will help us to avoid the question.
Yeah, thanks a lot.
Yes.
Okay, I hope my voice is coming clear.
Yes.
Yeah. Okay, thank you. So I will be discussing it with regression. Actually, I will be relating this with regression so that you all have an idea of what exactly factor analysis is. Now, it is a multivariate research technique, multivariate analysis tool, which I'm sure you all know what is multivariate. Multivariate basically means that when we are working on and when we are handling more than two variables at a time, then it becomes multivariate. So, the way how we do the analysis is that first we start with univariate. Univariate means you are dealing with a single variable. Then we come to bivariate. Bivariate means you are dealing with two variables. And then it is multivariate, where there are more than two variables which are on which analysis is performed. Now, so this is a multivariate technique, factor analysis. Now, one difference that exists between regression and factor analysis is that both of them are multivariate, right? Now, what is the difference between the two? Regression is a dependence technique. Now, what do I mean when I say dependence? Dependence means that you have a y. Y means a dependent variable, and you have one or more than one independent variable. For example, if I say that a person will have like the blood sugar level of an individual, random blood sugar level, suppose it is Y, that is dependent variable. Now, what are the factors that could affect your random blood sugar? It could be your age, it could be your weight, then it could be your say like blood pressure. Normally people who have high blood pressure tend to have high blood sugar as well, and many other factors which can cause high blood sugar, or which can rather affect your blood sugar level. So then you have a Y and you have one or more than one independent variable. So this type of multivariate technique or multivariate analysis is known as dependence technique or dependence analysis. However, on the other hand, there is interdependence technique. Now, factor analysis is a type of interdependence technique. I am repeating this term. It's also written on the slides if you can see the third point of the slide. Factor analysis is an interdependence technique. Now, what actually interdependence means? In interdependence, there is no concept of Y and X. By Y and X, I mean that when we talk about factor analysis, there is no concept of dependent and independent variable. You just have a set of variables which you are assuming that those set of variables are highly correlated with each other. The only condition that should be fulfilled when we apply factor analysis, or rather when we should apply factor analysis, is that we have set of variables. We don't know which is dependent on which, so there is no dependence concept here. You just have a set of variables, and you know that these set of variables are highly related with each other. There is some sort of correlation between these set of variables. Then we generally perform factor analysis. Now, why do we perform factor and what factor analysis actually does? This is a dimension reduction technique. It is a multivariate technique, that is clear to all of you, because you are dealing with more than two variables at a time. You are dealing with several variables at a time. That is one thing. Second, it is an interdependence technique. That is also clear to all of you, because you are not dealing with the concept of dependent and independent. We just have a set of variables and we are assuming that these set of variables are highly related with each other. That is number two. Number three is that these variables, this technique, factor analysis, is a dimension reduction technique. Now, what actually dimension reduction means? I'll give you an example. Maybe then you will be able to understand it better. Suppose we have a scale that is used to check whether an individual has depression or not. I think you all, like most of you are from medical or from like social sciences background. So you all must be aware that in behavioral and social sciences, we generally have these kind of scales that are used to measure your depression level, your anxiety level, and so on. Because you cannot just like height, weight, you cannot measure it by one single tool, right? So what we do, we have these kind of scales that are used to measure these kind of social traits, that whether you have depression or you have anxiety. Now, suppose if I have a scale, by scale I mean a questionnaire that I have developed, that I have made, and I have developed it to check that whether an individual has depression or not. Okay. Now it's my questionnaire, so I have put in questions on it. Now, when the data was collected for that questionnaire, on that questionnaire, I saw from the preliminary analysis that the way the questionnaire has been made, there are a lot of variables which I feel are similar to each other. So I made this questionnaire or tool, like any one of us, like we made this tool. And while making this tool, we realized when we were collecting the data that there were many variables which were found to be similar to each other. Okay. We felt that there were two or three questions which were used to ask the same trait, or which were checking the same characteristic, like this. If something like this happens, then what do we do, or what should we do? In that case, we go in for dimension reduction technique. And one way to reduce the dimension of your data is by applying factor analysis. It is a dimension reduction technique. Now, how does it reduce the dimension? I see that there are many variables which I have used to assess that whether an individual has depression or not. Now, I could see that there are many variables that were used. Okay. out of those variables, I want some reduced set which maybe works on lesser number of variables, and by which I can assess that whether an individual has depression or not. So instead of collecting data on, say, 40 questions which are focusing on depression, it would be very convenient for me as well as the person who is answering that if he or she is only collecting data on maybe 5, 6, or 10 questions, I think you all will agree to it, that instead of asking like 40, 60 questions, it would be good if you are able to reduce the dimension and if you are able to ask questions not on all, but on like fewer number of variables, right? So this type of technique is known as factor analysis, and this is done by so this is known as dimension reduction, and it is performed by factor analysis. What exactly this technique does? It tries to find out the latent or the underlying structure present in the data. Now, I think latent is is a word which is very, very commonly used whenever we talk about factor analysis. Latent means hidden. So I am able to see these 40 variables, okay, which I have collected. Suppose if I am able to see these 40 variables, but suppose if I try to perform dimension reduction, or maybe I try to perform factor analysis, then I am able to see, I'm able to reduce the dimension of these 40 variables into, say, 5, 6, or 7 uh, factors which are not apparently visible. Like in the data, you are not able to see those variables, but you can, in the data, those variables are not visible, but those variables are hidden, they are latent, they are underlying, and they are present in your data. So what factor analysis does, it sort of creates groups. I think group is maybe not a appropriate word. It creates collection of variables which are correlated with each other, and it forms factors out of those variables. So suppose if there are 40 variables present in your tool or your questionnaire, then factor analysis tries to first of all identify that out of these 40 variables, which of them are highly related with each other. Okay, and then after it has found out that which variables are highly related, then it makes their subgroups. And those subgroups, or those like groups, in those groups, there are those type of variables which are highly correlated with each other. And those groups are called factors. And they tell you about the hidden structure that is present in your data. Hidden structure, why I'm saying? Because it is not apparent by these 40 questions, but these structures are present. This structure is present in your data. That is why factor analysis is called dimension reduction and an interdependence technique. Okay. I can see a lot of chats that are going on. Yes, it is beneficial in developing the questionnaire. Please change the slide. I have yet not changed the slide. Let me first explain what I'm trying to explain, and then I will change the slide. Please don't worry about the slides. Try to concentrate on what I am teaching. Okay. I am trying to explain the very basic concept. Don't worry about the slides. All right. Yes. So, yes, I think you very rightly said, Mr. Rivello, that yes, factor analysis is beneficial in developing questionnaires. Factor analysis is highly used when we develop a questionnaire. But this knowledge will only be known after data collection. So how can it be used in developing questionnaire? Now, there is some concept, Mr. Saurabh, which is called uh, pilot analysis or pilot study. If you would have heard of this concept, generally, whenever a tool is developed, what happens is that we first try to collect the data on 20, 30 individuals. That is known as a pilot survey. On the basis of that data, we get the results. We try to do certain analysis. I think in various studies, you would have, yes, it's not necessary that it should be 50. It can be 20, 30, 50, depending on how plausible it is, how feasible it is. Okay. So we conduct a pilot study. On the basis of pilot study, we try to find out the reliability, validity of our tool. We try to establish that. And then we go ahead with the revised tool or the questionnaire and then perform the analysis. So some people, they go for factor analysis while they are developing the tool so that their tool is properly validated. Okay. So I hope the doubts and the queries are clear. Now, this type of factor analysis, which we are going to discuss here, is called exploratory factor analysis. There are factor analysis is actually broadly classified into two sections: exploratory factor analysis and confirmatory factor analysis. Just as we talk about descriptive statistics and inferential statistics, I think it is very similar to that. Exploratory factor analysis gives you an idea that whether first of all, whether you are able to reduce the dimension of the data. Second, are you able to create the factors? And third, if yes, then how many factors and which variable come under which factor? So it sort of performs, it is a preliminary analysis, which we will do right now. Confirmatory factor analysis further validates the results of exploratory factor analysis, and it also tests the hypothesis of this relationship. So confirmatory factor analysis is actually performed using an AMOS software. If we talk about SPSS, then there is an advanced add-on module for factor analysis, for confirmatory factor analysis, which is called structural equation modeling, SEM. Okay, now for that SEM, there is an add-on module which is called AMOS of SPSS, by which we can perform confirmatory factor analysis. Now, some people might have this doubt that like is it always mandatory that we perform both EFA and CFA? So the answer is no. You can perform EFA and you can reduce the dimension of your data. Further, if you want to like test the hypothesis, confirm your findings of EFA, and if you have like easy access to AMOS and other, then you should go in for confirmatory factor analysis. Otherwise, just doing EFA would be fine. So we have one question from Dr. Vinay. Do we need to purchase the module for factor? For EFA, you don't need to purchase any additional module. If you have SPSS software, then in that software only there is an option by which you can perform EFA. But yes, EFA means exploratory factor analysis. So if you have, if you just want to perform exploratory factor analysis, then you just need normal SPSS and you can do it. But if you also want to perform confirmatory factor analysis, then you have to purchase AMOS. There is an add-on module of SPSS which is called AMOS, AMOS, by which you can perform confirmatory factor analysis, which is in which the analysis is called structural equation modeling, SEM. But don't worry about CFA. Right now, we will just be focusing on exploratory factor analysis. Okay. So this is the basic difference between the two. If you can see on the slide, EFA tells you that whether you can reduce the dimension of the data. If yes, then how many factors? And confirmatory factor analysis further tests the hypothesis. Now, what exactly factor analysis does and why it is used? The first thing why we use factor analysis is when we have large data sets and several number of variables. Now, by large data set, I think many of you must have this doubt that what actually large data set means. So the thumb rule is that suppose you have 40 variables. I mean, just now I gave this example of depression scale. In the depression scale, suppose if I have 40 variables. So the rule of thumb is for each variable, you should have at least 10 times of the number of observations. Some people say that it should be 15 times. Some people say it should be 20 times. But ideally, at least it should be 10 times of the number of variables. But this does not mean that your sample size should depend on this. Please be very clear that sample size is calculated according to the study design and according to the study objectives. The primary outcomes, secondary outcomes, primary objective, secondary objective. So sample size estimation or calculation is an entirely different theory. So please don't think that suppose if we have 40 variables or 40 questions in our tool, then it'll be okay if we go in for a 400 observation data. No, I'm saying at least you should have 400 observations. Only then applying these types of multivariate techniques would be good. Because if you don't have a large data set and if you go in for these kind of techniques, it is not justified. Sometimes people come to us, they have 20, 30 observations and they say that like 30 observations, 7, 8 variables, and they say that hame isme factor analysis karna hai. We have to go in for factor. So that is not the right approach. At least you should have a large data set because since it's a multivariate technique and there are lot of, just now you will see the results of factor analysis when we do the hands-on, and then you will realize that since there are lot of like mathematical calculation that goes on, if you have a small data sets, the results are sometimes spurious. It is not able to converge properly. So it is very important that you have a properly you have a proper number of observations depending on the variables so that you are able to perform the analysis correctly. Okay. Now, I think this is why we use it. And yes, so this slide is very important. This actually discusses about different assumptions for factor analysis. What are the basic assumptions? Now, one which I already told to you all, that your observations should be highly correlated with each other. I think we have a question in the chat box. Can we do G power? And now G power is a different software. Yes, it is used for sample size calculations, but right now we are only focusing on SPSS. But yes, you can use G power for sample size. Observation means the the values that you have. Like each data is called observation here. Suppose you have 40 questions, तो जो response आ रहा होगा, I think Mansi has asked this question. तो जो response आ रहा होगा, the response that you will be getting, Mansi, that is the observation. Okay. Yeah. So now what are the requirements for factor analysis? Number one, there has to be univariate and multivariate normality within the data. Very, very important. Now, univariate normality means that each variable should be normally distributed. Suppose we have 40 variables, then all these 40 variables should be normally distributed. Multivariate normality means that together all these variables should be normally distributed. Now, in SPSS, unfortunately, we do not have a test that checks for multivariate normality. So what we do, we go and check for separate univariate normality. Univariate means separately we check for each variable that whether it is normally distributed, and then we perform factor analysis. But otherwise, if you have a software that checks for multivariate normality also, then rather than checking for univariate normality, you should go in and check that whether there is multivariate normality or not. Now, I have told you all about the test which checks for univariate normality. Can anybody write on the chat box the name of the test that checks for normality? I did discuss with all of you in the previous class. Shapiro-Wilks. Okay, very good. And Kolmogorov-Smirnov. Great. Thank you so much. So these are the tests which checks for univariate normality. Now, one test which checks for multivariate normality. Can anybody tell the name of that test? This could be a quiz to all of you. If you tell, then it's okay. Otherwise, I'm there. Right. So the test that checks for multivariate normality is known as Mardia's test. M-A-R-D-I-A. I'm repeating the spelling once again. M-A-R-D-I-A. This is performed on our software. It is also performed on Stata. But unfortunately, this test has yet not been included in SPSS. But this is a test. I mean, this is just for knowledge of all of you. You should know that there's a test called Mardia's test, which checks for multivariate normality. Okay. So if this test is available, you can put all the variables together and check. Otherwise, you can go for univariate normality. That is one assumption. Second is, there is an absence of univariate and multivariate outliers. Very, very important. There should be no outlier present in the data if you have to perform factor analysis. How to check for outlier? I'm sure you must have studied box plot. Yes, very good. So box plot is one way by which you can check and identify outliers and remove them from your data set. So ideally, there should be no outliers if we perform factor analysis. What is an outlier? Okay. Now, outlier is an observation that is present in your data, but it behaves in a different manner, in a manner that is different from the rest of the observation. I'll give you an example. Suppose if I take height of all of you, okay. Now, some of you must be having, like most of us are Indian population, they have height around 5, 4, 10 se lekar ke, it goes up to 5, 5, 5, 9, 5, 10, even 6, 6, 1, like this. Some of you must be having height as 6'2", 6'3", like they are. So these type of observations are called outliers because there are very few people who will be having height above 6 feet, right? Or like which are 4, 5, 4, 6 on the lower side. Some of you must be having height on the lower side. These type of observations are called outliers. Then there is another term which is called extreme observation. Please be sure, everybody, that outlier and extreme observations are two very different things which are present in your data. Please do not confuse between the two, and please do not use these two terms simultaneously. I mean, they are not synonyms of each other. Some of you having height equal to 6'2" or 6'3", they could be outliers. But if anybody has height equal to 6'5" or 6'6" or 6'10", that is an extreme observation. So outliers are present in your data, and they should be present in your data because they actually define the nature of your data. Whether it is normally distributed, whether it is not normally distributed. Outliers are sometimes very important to understand the data. But if there are extreme observations present in your data, then they should be properly investigated. Agar aapne box plot dekha hoga, if you people must have seen the box plot, then in the box plot only, outliers are denoted by O and extreme observations are denoted by star, asterisks, right? Whenever you check for outliers, then do check for extreme observations, and each extreme observation in the data should be investigated. Agar such hai, then you can keep it in the data. Otherwise, you have to recheck. So this is actually a part of data pre-processing or data cleaning. Okay, so I'm not going into that detail. So that's about the second assumption. Then into the third one, there is a linear relationship between the factor and the variables. So as I already said, that variables should be linearly related with each other, जो कि correlation से check होता है, and we'll do that. A factor should have at least 3 variables, although this depends on the design of the study. Now, when we make the factors, we have to be sure that there are at least 3 variables in that factor. If you have less than 3 variables, it is not the right approach. But like just saying that you should have 3 variables, that is also not a very appropriate, or I would say this is also not a cutoff rule. It definitely depends on the design of your study. Okay. Now, what are the further requirements? So mostly it is performed on metric variable. Metric means continuous. Continuous, as I said, they should be normally distributed, and they should be on a continuous scale. So normally it is performed on metric variables only, but if it is performed on non-metric, then there is a concept of dummy variables, which is again an advanced concept. So then you should go in for like dummy variables factor analysis. We will not be discussing that right now, but that is also one way to do it. Now here it is written that there should be at least 15 to 20 observations per variable. But I mean, sometimes it's not possible to go in for 15 to 20. So minimum you should have 10 times of the number of observations. So if you have 40 variables, you should have a sample size of at least 400. All right. Then your results would be proper. So these are again some of the assumptions, that there should be no outlier, then no perfect multicollinearity. I think multicollinearity, if you all must have studied about regression, then you know that multicollinearity is that variables are highly correlated with each other. So they should be correlated, but they should not be perfectly correlated. So they should be correlated with each other, but they should not be perfectly correlated. मतलब one नहीं होना चाहिए correlation coefficient, but yes, one नहीं होना चाहिए, but they should be correlated. Okay, then since factor analysis is a linear function of measured variables, it does not require homoscedasticity between the variables. So homoscedasticity means equal variances. Normally, when you check in for correlation and other things, Homoscedasticity is also checked, so you don't need to separately check for this assumption. Okay, then linearity, as I already said, there should be linear relationship, interval data or metric scale, and adequate sample size, which I have already discussed. Now, one way by which we can check for the correlation is that we make a correlation matrix. Now, you all know what is a correlation matrix. When we try to calculate the correlation of several variables, then we get it in the form of a matrix. Or yes, you're right. We can also plot a scatter plot, and by seeing a scatter plot, also we can visually inspect the correlation. One way is that. Now, the problem with scatter matrix or correlation matrix is that if we have many variables, then sometimes it is difficult to interpret. Matlab, like suppose if we have 40 variables, then you will have a 40 cross 40 matrix. So it's a huge matrix. I will show it to you when we do it on SPSS right now. So if you have a huge matrix, then you will have a huge data, matlab, थोड़ा बड़ा सा वो matrix होगा, and which sometimes is difficult to interpret. So in order to get it easy, there is a test which is called Bartlett's test of sphericity. Now this test is performed in order to check that whether your data is suitable for factor analysis or not. Okay, it is known as Bartlett's test of sphericity. Now, since it is a test, so it will have some null hypothesis and it will have an alternative hypothesis. The null hypothesis for Bartlett's test is that correlation matrix is an identity matrix. Now, can anybody tell me what is an identity matrix? I think we might have some. Okay, I think Ritik has very rightly said 1 0 1 0 diagonal elements are 1. Okay, great. So identity matrix means that diagonal elements are 1 and off diagonal elements are 0. What does off diagonal elements means? The elements which are other than the diagonal. That's an identity matrix. Okay, I'm repeating it once again. Identity matrix means that diagonal elements are 1 and off diagonal elements are 0. Now, coming back to Bartlett's test of sphericity, the null hypothesis is that correlation matrix is an identity matrix. Identity means that diagonal would be 1. So, what does diagonal mean here? For a correlation matrix, diagonal would mean that उसी variable का उसी के साथ correlation, है ना? So obviously the variable would be highly correlated to the same variable, वो तो 1 होगा ही. Off diagonal elements 0 means that the rest of the variables are not correlated with each other. So ideally, if you have to perform factor analysis, this hypothesis should be rejected. That is, p-value should come less than 0.05. Very, very important. I'm repeating it once again. Before you perform factor analysis, please perform this test, Bartlett's test of sphericity. SPSS does it by default. I will show it to you. The null hypothesis for this test is that correlation matrix is an identity matrix, and this null hypothesis should be rejected. Only then you should go ahead with factor analysis. Means the p-value or the SIG should be less than 0.05. Okay, I hope I'm clear to all of you. Now, one more measure along with Bartlett's test for sphericity, which is performed, is known as KMO measure of sampling adequacy. This also checks that whether your data is suitable for factor analysis or not. Is my slide not visible to all of you? Can you all see the KMO measure of sampling adequacy? Yeah, I did receive a message, please change the slide, so I thought, okay. So this KMO measure is also used to check that whether your data is suitable for factor analysis or not. So both Bartlett's test and KMO measure is performed to see whether your data is fit or not. So for KMO, the value should be, it should be at least more than 0.7. You can see in the interpretation that is given here. If it is 0.9, it is excellent. If it is 0.8, it is good. Even if it is 0.7, it is good. If it is less than 0.7, then I mean, it shows that your data is not very appropriate for factor. So ideally, this value should be more than 0.7 KMO measure. Okay. And this is also done in SPSS after Bartlett's test of sphericity. Coming to one of the methods by which we perform factor analysis, and that is known as principal component analysis, PCA. Now, while we do factor analysis on SPSS right now, after this session, we will do it using principal component analysis. So PCA is one method by which you can perform dimension reduction or factor analysis. There are other methods also by which we can perform factor analysis. One is known as principal axis. There are a lot of methods, but we will be, like today, in today's class, we will be discussing about principal component analysis. What is special about this? First of all, it is performed on metric scale variables, that is continuous data. Secondly, it works on the concept of correlation, जो हमने अभी discuss किया. Variables which are highly correlated with each other are put in together in one factor. Then variable, so basically it performs the grouping on the basis of correlation. कोई तो क्राइटेरिया होना चाहिए ना जिसके बेसिस पर आप उनको क्लब करेंगे. So principal component analysis uses the concept of correlation to create the factors, to create the groups, to create the underlying factors which are present in your data. Okay, so we will be discussing about, we will be studying PCA, which is one method to perform factor analysis or to perform dimension reduction. Okay. Now, KMO and Bartlett's test we have already discussed. Yes, one more very, very important concept that will come in the output when we will perform factor analysis is known as communality. Before I tell you all about the concept of communality or eigenvalue, it is important that I should tell you all the importance of variance and why is variability very important when we talk about factor analysis. Now, suppose if, try to understand what I'm saying. Please don't see the slides. I will discuss about the slides. Right now, please focus on what I'm explaining. Why is the concept of variance very important when we talk about factor analysis? Now, suppose if I have taken a scale which measures depression and there are say 40 questions which are trying to measure that whether an individual has depression or not. Suppose if there are 400 observations and 40 questions. Suppose if there is not much variation in the data, right? Variation means if all the observations are almost similar, then what does it shows? ऐसा तो हो नहीं सकता that for all the 400 individual, their mental state would be exactly same. Definitely somebody would be on a very happier, like happier phase or happier time. Somebody would definitely be on a, like, having high depression or high, like low feel or something like that. ऐसा तो बिल्कुल भी नहीं होगा that all the 400 individuals would have almost same type of response. So if you are getting responses or observations which are having very less variation or which are not having higher variation, then this means that your tool or your questionnaire is not properly created. It is not addressing the addressing your objective. It is not focusing on the basic concept which is required to measure. Yes, specificity is not true exactly. It is not, so it is not valid. It is not fulfilling the objective with which it was created, right? That is why it is very important to have high variability in the observations. Higher the variability indicates that your objective is being fulfilled properly. So, higher the objective means that, higher the variability means that your objective is being fulfilled properly. So, factor analysis works on this concept of variance, right? It tries to maximize the variance that is being explained by overall data and that is being explained by each and every factor or each and every component. So factor is also called as component here. Factor analysis tries to maximize the variation. Now there is one question, variance between the groups or within a group. It is definitely between. Here we are not talking about within variance at all. It is that how much that particular factor is able to, how much variation that particular factor is able to explain. Higher the variation, definitely it is better. Just now I've explained, I hope the concept is clear. Higher the variation, it is trying to fulfill the objective with which it has been designed. Lesser the variation, it is not able to explain the objective or not able to fulfill the objective. So factor analysis tries to maximize the variation for the factors and also overall variation. Okay, so communality is one concept which is also which also works on variation. It is the sum of squared component loading and it represents the amount of variance in that variable which is accounted for by all the components. So for each variable, like suppose you have 40 variables, for each 40 variable, you will have separate value of communality. Higher communality means it is able to explain higher variance. Simple. Higher value of communality means it is able to explain higher variance. And those variables which are able to explain higher variance should be kept in your data. Okay. Then there is a scree plot which is also used to graphically decide how many components or how many factors should be made. because whenever we, just now I said that dimension reduction, like factor analysis, is a way to reduce the dimension. So if suppose we have to reduce the dimension of 40 variables into 5, 6, or like 7 factors or components, then first thing we have to decide that how many, like into how many components should we reduce, right? That is the first thing. So to decide that how many factors or how many components should be used, we have to make a scree plot. I think you very rightly said that when we do all this in SPSS, it will be more clear to all of you. But these concepts I am just explaining to you so that you have a broad idea of what these terms actually mean. Now, there are some of the drawbacks or limitations of factor analysis also. One of the limitations is that sometimes the factors that you make, it is difficult to interpret because uh, sometimes the way it groups the variables, what happens is that they are not correlated with each other. Sometimes it's wrongly, it creates the groups. Then naming of the factor is important, like it's difficult. It is definitely done by the researcher, but sometimes researchers are not able to name the factors properly. Sometimes it is difficult to interpret. So to avoid all these things, number one is make sure that your assumptions are properly fulfilled. By assumptions, I mean all those assumptions which I have discussed in detail. Make sure that they are properly fulfilled. If your assumptions are fulfilled, none of these problems would occur. Okay. So these are some of the limitations. Now, I think it's enough with the theory portion. We should now go in for hands-on using SPSS. So I think I should start with the SPSS data file. Should open that. Any questions if you all have, you may write in the chat box so that we can take questions in 2-3 minutes. What is principal component? Okay. It is a way to perform factor analysis. Component means factors. So principal component, we try to create components or we try to create factors by which we reduce the dimension of our data. So PCA is one way to reduce, to perform factor analysis. Please explain Pearson correlation coefficient. Now, it's a correlation between two variables which should be normally distributed. That is Pearson correlation. Okay. Are factors called as groups containing highly related variables? Yes. Very rightly said, Ritik. Factors are, they are called groups, they are called components. They contain variables which are highly correlated. Okay. Factors are hidden variables. Yes. Bharat very rightly said. Hidden इसलिए कहते हैं because they are not apparently visible in the data. I will show you my data set on which we will be doing factor analysis. Is my screen visible to all of you? You can write yes on the chat box if the screen is visible. Now this is a data which was it's a real data, of course, and this data set was basically made to assess personality of individual. And if you see the variable view, there are 44 questions which were asked about personalities of individuals. Like what are the traits of personality? इनका label अगर हम देखें तो पर्सनालिटी में क्या हो सकता है? अ पर्सन कुड बी टॉकेटिव, finding faults, does a thorough job, depressed, original in the thinking, reserved, helpful, careless, relaxed, curious, full of energy. ऐसे करके बहुत सारे characteristics हैं. Some of them are like disorganized, forgiving. Now there are 44 different characteristics which are, yes, 44 variables. Yes. 44 variables, 44 characteristics which are used to assess the personality of individual. अब ऐसा लगा कि 44 तो बहुत ज्यादा है. Let us try to reduce the dimension. Let us try to group these 44 variable into highly correlated components or highly correlated factors. So for that, we will perform factor analysis or principal component analysis. Okay, I hope the data is clear to all of you. And since it is like you have 44 variables, so number of observations kitne hain? Let us see. We have 459 observations. So as I said, it should be at least 10 times. So at least 450 440 to hone chahiye. So here we have 459 observations and 44 variables. Now I have a question. What are the observations based on? It has been collected using the questionnaire, right? Ordinal scale का questionnaire था. उसमें सबसे बोला गया कि आप ranking करिए. So on a scale of 1 to 5, they have ranked. So based on data obtained from pilot study, we do factor analysis before starting the original. Yes, you can. It's not mandatory, but if you do it, it will be good. So each personality type has response to a common questionnaire. Each person was given a questionnaire. There are 44 questions. Each person was given this questionnaire. On the basis of this questionnaire, individual was asked to give rating on the basis of 1 to 5. Like suppose if I was given this questionnaire and I start from talkative. Now I know on a scale of 1 to 5, I can say that how talkative I am. So I can give myself some, like on a scale of 1 to 5, I can give myself ranking. Each and every one of you can give yourself ranking, right? Finding fault. Are you able to do a thorough job? How depressed you feeling? How original you are? How reserved you are? Each and every one of us know about all these traits, right? So हमें अगर ये questionnaire दिया जाएगा, so I can I can respond on all these 44 questions on a scale of 1 to 5. This is a Likert scale, right? Is this clear to all of you? So there are participants and pers means personality trait. Yes, it is the name of the variable. Just I have given the name of the variable pers01 to check the assumption of multivariate normality on this ordinal data. Yes, you can check here also, but since we don't have multivariate test, so I'm not doing it right now, but you can check. Should the responses be framed in Likert scale for doing factor analysis? Yes. You can do factor analysis if the observations are on Likert scale, ordinal, or if the observations are on a continuous scale. So one person was asked 44 questions. Yes, Dr. Vaishali. Each 459 individuals were asked 44 questions. Okay. So I hope the data and the structure of the data is clear to all of you. So if the data is clear, then let us go ahead and see how to perform factor analysis. Okay. Analyze. Can anybody have a guess that from which option can we perform factor analysis? Let me see how attentive you all are in the lecture. Dimension reduction. Okay, very good. Have you all done it before or just after the lecture? This is the response. After lecture, okay. Now somebody has written AMOS. Now AMOS is used only for confirmatory factor, as I said. Here, since we are only doing exploratory factor analysis, so here we will go by dimension reduction. So analyze, dimension reduction, and factor. I am repeating it once again. Analyze, dimension reduction, and factor. You can take the screenshot, you can write it on your notes that you remember the path by which you can perform factor analysis. Analyze, dimension reduction, and factor. Click here. So now there are 44 variables and you have to reduce the dimension of these 44 variables. Select all of them, put it on the right. How to do it? Manually एक एक को select करके right में डाल सकते हैं या फिर you select the first one, press shift and down arrow, keep on selecting all the variables. Yes, control A also, and put them on the right. Selected all the variables and put it in the variable section because I have to perform dimension reduction on all these 44 variables. Now click on descriptives. In the descriptives, click on univariate descriptive, coefficient, KMO and Bartlett's test of sphericity. I am repeating it once again. Initial solution was already selected. You have to click on univariate descriptive, coefficients, and KMO and Bartlett's test of sphericity. Click on continue. Okay. Then go to extraction. Now these are different types of methods by which you can perform factor analysis. Principal component is one method जिसके बारे में हमने discuss भी किया, PCA जिसको बोलते हैं. We will be doing that only. But what are the other types of methods? Generalized least square, unweighted least square, maximum likelihood, principal axis factoring. Actually, how we decide that which type of method should be used depends on many things. It depends on your variable type. इसमें से कई सारे methods ऐसे हैं which you cannot perform on ordinal scale. Like Ritik is asking about MLE. MLE is the maximum likelihood. You cannot perform maximum likelihood on an ordinal scale variable. थोड़ा सा ज्यादा stats हो जाता है इसमें, but broadly, principal component is one very, I would say, safe method by which you can perform factor analysis. And You can do it on variables which are ordinal scale. You can do it on variables which are continuous as well as ordinal both. So principal component is one safe method by which we can do, and it is very, very commonly used also. So we generally go in for principal component method only. Okay. Now, if you are going for principal component, make sure that in the analyze section, correlation matrix is selected. Because as I said, principal component works on the concept of correlation. It makes the components or factors only on the basis of the fact that they should be highly correlated with each other. Okay. So if in the method section principal component is selected, then in the analyze correlation matrix should be selected. By default ऐसा रहता है, but make sure you are not changing it, right? In the display, unrotated factor solution is already clicked. You have to also click on scree plot. Very important to decide optimum number of factors. Optimum number of factor means how many factors should be there, how many components should be there. अभी हमें ये नहीं पता that 44 variables have to be reduced into how many components. That is decided by scree plot. Okay. So click on that. Now here there is one more way by which we can decide on optimum number of factors. That is based on eigenvalue. What exactly I will explain you after we go ahead with the output. So as of now, just make sure that जो ये default setting है, ये रहे. That eigenvalues should be greater than 1. Why it is greater than 1, I will explain you when we go in with the outputs. Okay. Here it is written maximum iterations for convergence 25. It should be 25. I will tell you what this means when we go in for the output. Just remember all these concepts. We will discuss in detail when we discuss the output. As of now, just try to remember these things. Okay. So once again, method should be principal component. In analyze, it should be correlation matrix. Then in the display section, it should be, you should click on scree plot. Then in the extract based on eigenvalues, it should be greater than 1. I'm taking a lecture. Okay. Then click on continue. Then click on rotation. Now in the rotation, click on vary max. Why I am doing it? This will also be explained in the output. So I hope you people are writing it down or taking screenshots, whatever. That is why I'm going slow. So in the method section, click on vary max. Then in display, click on rotated. It is by default click, so you don't have to change anything. Iterations for convergence 25. Iteration means repetition. And convergence means coming to one value. So iterations for convergence means that how many times it should be repeated so that you come to one single answer. So it should be 25. Why it should be 25? I'll tell you. Okay. So what we have done here, we have clicked on vary max rotation. Then click on continue. Then in the scores, click on Save as Variables. In the scores, click on Save as Variables. Dr. Anand, I'll repeat the entire process once again. Let me first complete it and then I will repeat the entire process once again before I go into the output. Okay. So in the score section, click on Save as Variables. Click on Continue. Then click on Options. Now in the option, right now, I am not clicking on any option. But later on, I will show it to you how easy it becomes if you click on this option, Sort by Size. Abhi mat kariyega isko. Right now, please don't do it. I will tell you after we have done like the first interpretation of the output, then I will tell you how beautiful it is if we sort it by size. This is very, very, very useful option in case of factor analysis. But right now, please don't do it. So just let it be, okay? Now I'm repeating, before I click on OK and we get the output results, I'm repeating the entire process once again. So if anybody of you has missed any option, then you can recheck it, right? So I'm closing this window, go to Analyze, go to Dimension Reduction because it is a dimension reduction technique. Click on Factor. Select all the variables and put it on the right. All 44 variables. Click on Descriptives. Click on Univariate Descriptive. Then click on Coefficient. Click on KMO and Bartlett's test of sphericity. Then click on Extraction. By default, principal component method is selected. In the Analyze section, correlation matrix. In the display, click on Scree plot. Then let it be like this. Maximum iterations 25. Continue. In rotation, click on Varimax. The rest of the options should be like this only. Then click on Continue. In the scores, click on Save as Variables. Click on Continue. Options, you don't have to do anything right now. Later on, we will do it. So I hope everybody has noted down how do we do this on SPSS. So should I run the output now? Yes, okay. I think Dr. Anand, it must be clear to you also. So let us run this and see how are the results. Now these are different types of results which we've got using factor. Now just see how much it has done. Now I will tell you that I teach statistics and it's been around, it's going to be 9 years now since I've been teaching. And the students, like in MSc, we teach these concepts of multivariate. Dr. Yadav must like, he must agree to what I'm saying, that in masters, we teach these concepts of factor analysis. And the students, like they take about 2-3 practical classes. 2-3 classes means about 6-7 hours to complete all this calculation manually, which this software has done for you in, I think, not even a minute. It did not take even 1 full minute to complete all this analysis. So this is how easy computer and software has made our lives. But at the same time, it is not good also because it has stopped us from thinking, from doing hard work. So that is why our students do all this manually. So these are all the results that software can do it in couple of seconds. So let us start interpretation now. And let us start with the first table. Okay. Now this is descriptive statistics, which shows you mean, standard deviation, and how many observations were used for the analysis. 433 observations were used for the analysis. क्यों यहाँ पे 433 लिख रहा है? हमारे पास तो 459 थे. Because there may be some observations which may be missing for some variables. So what it does, it only performs the analysis on those variables which are complete, on those variables which are non-missing. So basically, your non-missing data is 433. So your effective sample size has reduced to 433. From 459, it has reduced to 433. That's okay. If you are sure that you don't have missing observations, then you can go for that also. Is the data collected ordinal? Yes, the data is on an ordinal scale only. Likert is ordinal. Okay. So it is on a scale of 1 to 5. So it is ordinal. So first table is descriptive statistics. इसका बहुत ज़्यादा use नहीं है. Generally, when we do a research paper, first table we put an ordinal scale variable. So descriptive statistics is required there. Let us ignore it and move to the second. Now this is correlation matrix. Now, if you can see, it is a correlation matrix between 44 variables. These 44 variables you have here, and these 44 variables you also have on the y-axis. So you have it on the x and y both. Now this is a correlation matrix. Diagonal elements are 1 and off diagonal elements are, they are not 1, there is some value in the off diagonal element, as you all can see. Now there is a question, we need continuous metric variables. We can perform correlation on ordinal also. It is called Spearman rank correlation. So if you have ordinal variables, then software automatically performs Spearman rank correlation. So principal component analysis can be applied on a metric data, and it can also be applied on ordinal scale variables. Since we have ordinal scale, so software is performing Pearson, rather than Pearson, it is performing Spearman, it is calculating Spearman rank correlation. Is this clear to all of you? Explain diagonal value. Okay. Now diagonal means, can you all see where is my mouse? The cursor of my mouse, can you all see it? If you see these 1 values, these are called diagonal elements. So talkative का talkative के साथ correlation 1 ही होगा obviously. Finds fault का finds fault के साथ correlation 1 ही होगा. Does a thorough job का इसके साथ. So a variable with itself will always have correlation value 1. So always whenever we make a diagonal, whenever we make a correlation matrix, diagonal elements will always be 1. Okay. Now, this is a problem which happens when we have many variables. अब इसको कैसे interpret करेंगे हम? how are we going to do the interpretation? Just by looking at the correlation matrix, it is very difficult. किसी का correlation बहुत high लग रहा है ना? These are the coefficients that are given here, and I think you all must be aware that even if it is Spearman or Pearson correlation, the value lies between -1 to +1, है ना? So for some variables, I can see they are having high value. For some variable, I can see they are having less value, है ना? So how to interpret? So this is the problem which happens when we have to interpret the correlation matrix, and that too for many variables. So in this case, आप देख सकते हो, just see how huge is this table. यहाँ से शुरू होके it is going up to here, because it is 40 variables horizontally and 40 variables vertically. तो कैसे करेंगे आप इसका interpretation? It's very difficult. So in order to get rid of this thing only, there is this test which is done here, which is called Bartlett's test of sphericity, and the measure is known as KMO measure of sampling adequacy. I think we have discussed this in the theory portion just now. So in order to escape this, I mean, yes, people do report this correlation matrix in research papers also. I have seen several research articles which come to me for review. I have seen that many people, they do report correlation matrix, but I think it's of no use because it is very difficult to sort of interpret such a huge correlation matrix which goes from here to here. So in order to get rid of this huge interpretation, we can directly come to the KMO measure and Bartlett's test. So सबसे पहले, first thing you will see Bartlett's test of sphericity. Now here the null hypothesis is that correlation matrix is an identity matrix. Okay. So p value क्या है हमारी यहाँ पर? Since it's a test, so we will definitely have a p value. So what is our p value? The SIG is 0.000, which means it is less than 0.05. Since it is less than 0.05, what will we do? Accept or reject? What are we going to do? कोई बता सकते हैं? Okay, significant reject. Yes, Bharat. Om, okay. Reject the null hypothesis. Very good. Abhishek. So since we are going to reject the null hypothesis, hence we will conclude that correlation matrix is not an identity matrix. So पहला assumption fulfill हुआ that we should go ahead with factor analysis. I am repeating it once again. If this hypothesis gets accepted, you should not perform factor analysis. When paper comes for review to us, any of like statisticians, we always, if it is not mentioned in the research, like if the value of Bartlett's test and KMO measure is not mentioned in the table, then at least it should be mentioned in the literature of the paper. Whenever anybody does factor analysis, if these values are not mentioned in the text, then we definitely write it on the comments that both these values should be mentioned at least in the text, because these are important for you to decide that whether your data is suitable for factor analysis or not. So Bartlett's test hypothesis gets rejected and you conclude that your data is fit for factor and correlation matrix is not an identity matrix. Not an identity matrix means the remaining variables, that is the off diagonal element, वो zero नहीं है. Identity matrix का मतलब हुआ that off diagonal elements are zero, non diagonal are zero. So rejection means that non diagonal elements are not zero. Not zero का मतलब हुआ there is some correlation. Okay. which means that off-diagonal elements are highly correlated with each other. Next, we come to KMO measure of sampling adequacy. This also tells you that how suitable is your data for factor analysis. Kitna fit hai? Its value lies between 0 and 1. As I already said in the theory part, that if its value is more than 7.7, sorry, then you can say that you can go ahead with factor. Even if, yes, even if it is more than 0.6, sometimes it is acceptable. Actually, इसका भी कोई thumb rule नहीं होता. It depends on your type of study, depends on the design of your study, depends on many things. But generally, its value should be more than 0.7. 0.5 is less. 0.5 means that it is not very good data for factor. 0.7 and above should be taken for factor analysis. Okay. So is hamare case mein the value is coming 0.841, which is very good, which means that we can go ahead and perform factor analysis. Next is communality. Now again, for each 44 variable, communality tells you how much variability is being explained. Now this value again lies between 0 and 1. If it is near to 1, then we say that it is able to explain large amount of variation. If this value is near to 0, then we say that that particular variable is able to explain less variation. Now, what is the cutoff rule and how do we decide? If there is any variable that has communality less than 0.5, you can remove that variable from the factor analysis and again run the analysis. I am repeating it once again. If any variable has communality, this is this extraction. If any variable has the value of extraction less than 0.5, you can remove that variable and rerun your factor analysis. What happens if you do it? Number one, if the value is less than 5, it means that particular variable is not able to explain the variation properly. मतलब जो भी आपका टूल है, अगर डिप्रेशन का है या I mean whatever is the objective of your tool, it is not able to explain the variation properly. That particular variable is not able to explain the variation properly. Now, what happens if you remove that variable? If we remove a variable that is not able to explain proper variation, KMO measure often increases. कई बार ऐसा होता है that we design a questionnaire and we put some questions in the questionnaire which are not suitable. Useless questions भी हम अपने questionnaire में डाल देते हैं. Because of that, at times what happens is there are many variables which have extraction less than 0.5. It is of no use if you continue with those variables in the analysis. So if you are getting many variables which have extraction less than 0.5, you can remove those variables and rerun your factor analysis. It will help you in increasing the KMO measure. Okay, I hope this is clear to all of you. In our case, as we can see, there are some variables which have extraction less than 0.5. कौन से variables हैं? Okay, start squirrels has extraction less than 0.5, है ना? It is 0.445. Then forgiving has extraction less than 0.5. 0.351. I think there are only two variables which have extraction less than 0.5. Now, since in my data, like suppose आप इसी data पे analysis कर रहे होते, now there are 44 variables, and in the 44 variables, we only have two variables which have extraction less than 0.5, or maybe three variables. There is no need of removing them. Why? Because already your KMO measure is coming very good. So you can go ahead with these three variables also. 44 में अगर दो तीन variables रहेंगे भी in the analysis which do not have extraction more than 0.5, it is not wrong. You can go ahead with that variable also. ये वहां पे important होता है when suppose you have 44 variables and say 20 or 25 of them have communality less than 5, then you need to rethink. Less than 0.5 means it is not contributing to your objective, not fulfilling your objective. Okay, but here if we have 2-3 variables which are less than 0.5, we can go ahead because KMO measure is coming good. Anybody having any doubts still here? What is approx chi-square? Okay, when we perform Bartlett's test of sphericity, this is the test statistic. It is a chi-square test which is performed, and this is the value of test statistic. क्योंकि कोई भी टेस्ट होगा तो एक टेस्ट स्टैटिस्टिक तो आएगा, so this is just the value of test statistic. Okay, Sanju, I think the doubt should be clear. What does communality mean? Why are we concerned with extraction? I already discussed, Ritik, that communality is how much variation your variable is able to explain. So out of total variation, कितना percent variation वो variable explain कर रहा है. Extraction is the amount of variation it is able to explain. So higher the value, near the value to 1, better it is. I hope it is clear, Ritik. So after we have decided on the communality, going to the next table, that is variation explained. Again, now this is one of the most important tables when we perform factor analysis. But if everything is near 1, then how do we decide which has better contribution to? Not everything is near to 1. Some of the values are near to 1. Some values are lesser than 1. Every value is not near to 1. If you see the extraction, values are different. Those which are more than 0.5, those variables have to be retained. Okay? Right. So coming to this. Now basically this table is divided into 3 sections. If you can see, first is initial eigenvalue, then you have extraction, and then you have rotation. So first of all, I will begin with explaining what is initial eigenvalue. First of all, what is eigenvalue? Eigenvalue is basically how much variation the component is able to explain divided by total variation. So this eigenvalue should always be more than 1. More than 1 means that that particular factor or component is able to explain variation. So rule of thumb is that eigenvalue should be more than 1. That is number 1. Now, what is the objective of this table? As we know, factor analysis is a dimension reduction technique. So what we have to do? We have to first decide that these 44 variables should be reduced into how many dimensions? That is number 1 question. These, I'm repeating it once again, these 44 variables should be reduced into how many dimensions? There are 2 ways by which you can decide. One, on the basis of initial eigenvalue, and second, on the basis of this scree plot. Okay, remember we have selected the scree plot. So one, you can decide it on the basis of this scree plot, and another way is by looking at the value of initial eigenvalue. This. Okay. Now, if you see the scree plot first, let me first go into the scree plot and then I will go into the initial eigenvalue. This scree plot, on the x-axis, we have these 44 variables, and on the y-axis, we have their eigenvalue. How to interpret this scree plot? It should be in the shape of an elbow. You all know what is an elbow? Wherever there is first bend of the elbow. Now, the first bend of the elbow, wherever you see that bend, that is where we decide that those many components, like your data should be reduced into those many factors. By default, every software makes those many factors. Those like the number of factors is always the same as the number of variables. Suppose if you have 44 variables, so you will always have 44 factors. By default, you will have 44 factors. Now you have to decide that how many factors should be retained. Some people might say that I can see the bend at 7. Okay. Some of you might say that I can see the bend at 9. Some of you might say I can see the bend at 11. Is it? Some of you can say I can see the bend at 10. So this is the problem with the graph. What happens is that graphs are just an exploratory way. Some of you might feel that the bend is at 9. Some of you might feel the bend is at 7. That is why you cannot decide solely on the basis of the scree plot. This is the reason why so scree plot can just give you an idea. But to be decisive, we go to this table and we see initial eigenvalues. Now, as you can see in the first column of this table, it has calculated eigenvalues for all 44 variables, right? It has done it for all 44 variables. Those variables which have eigenvalue more than 1, that is the cutoff by which you decide how many factors or components should be made. So as you can see, there are 10 factors or 10 components which have total eigenvalue more than 1. That is why simple answer 44 components will now be reduced into 10 components or 10 factors. Is this clear to all of you? Coming to the next. Okay, one question, why 10? Because 10 factors or 10 components have eigenvalue more than 1. This is the rule by which we decide that your eigenvalue should be more than 1. More than 1 means it is able to explain much more variation. Okay. Now, how much variation is it able to explain? The first component always explains maximum variation. Remember. So it is explaining 16%. Second, 9.5. Third, 6.9. 4, 5.7, and so on. So 10th component is able to explain somewhere around 2.3% variation. So total variation kitna hua? If you see the third column here, it is showing you the cumulative percent. I think you all must know by now what's a cumulative percent. Add karte jate hain in sabko. So 10th component, it is able to explain 58.289% variation. So we can say that these 10 components which have eigenvalue more than 1 are able to explain 58.289% variation. This is the first section of this table. Okay. Questions? How do we see the variables included in the component? Please wait, Ritik. Let me go ahead with other tables. Abhi we are halfway with the interpretation. Please be patient. How to get the names of 10 components? Please wait. Gradually we are moving. I can go ahead and explain all of it to you at one go, but this concept is really advanced. So please try to understand. I'm trying to go slow so that all of you are able to understand. I will tell you how to name these factors. I will also tell you how to decide which variable goes into which factor. Please be patient. Okay. So first of all, we have decided that there are 10 components, and overall these 10 components are able to explain 58.289% variation. Now these three columns, which are after these three columns, this is just a repetition of these three. What it has done, उन 10 को अलग निकाल के रख दिया है बस. If you see, instead of all 44 together, it has just put these 10 components separately. So ये इन्हीं का repetition है. So I'm not repeating it again because it is just these 10 components have been separated out. Now the last three columns. Now if you remember, we did click on Varimax rotation, and I told you that we will be explaining it in the output section. Okay, I hope you all remember that. Now Varimax rotation, what it does, it tries to maximize the variation of each component, keeping the total variation fixed. I am repeating it once again. It tries to maximize the variation of each component, keeping the total variation fixed. So if you see here, total variation kitna aa raha hai? Can anybody write on the chat box? What is the total variation that your factor analysis is able to explain? 58.289. Very good. So now what the software has done, or what this Varimax rotation does, for each component, this was the initial variation, 16.5, 9.5, 6.9, 5.7, है ना, यहां से लिया गया था. Now it has tried to maximize each variation, जितना maximum हो सकता है. Why did it try to maximize? The reason why this was maximized was because this concept, this entire concept of PCA and factor analysis works on the basic fundamental of maximum variation. जितना maximum variation explain करेगा उतना बेहतर माना जाए. So this is the reason why it tries to maximize variation for each component, but total तो fix ही रखेंगे. That is why iterations are done. So if you remember that we had selected on maximum iteration 25. So this process goes on repeating until and unless variation for each component is maximized. Now there is one question which says it has reduced from 16 to 9. So how is it maximizing? पहले वाले component का 16 से 9 reduce हुआ है, but for other components it has increased. किसी का increase करने के लिए किसी का तो reduce करना पड़ेगा. You have to reach to an optimum number. What is optimum? Optimum is a number where you can say that this particular variable or this particular component has reached its maximum potential. So in order to increase the variation for some components, you will have to reduce it for some also, because you are fixing the total, right? So basically this concept means that you are trying to maximize the variation for each component. एक का 16 हो जाएगा, बाकियों का कम रहेगा, that is not the right approach. So we have to be sure that each component is able to explain higher, rather maximum variation. तो किसी का तो reduce होगा, किसी का बढ़ेगा, but you have to reach to an optimum point. And that optimum point is reached by repetition, by iteration. So if you see at the end of this table, it is this table or anywhere, okay, this table, it is written, somewhere it is written how many iterations. Yeah. So here you can see rotation converged in 16 iterations. Generally, it converges in 25 iterations within 25. So this is what iteration means. I hope it is clear, Mr. Ritik. So we are optimizing the variance. We can also go for equal variance, but homoscedasticity is not an acceptable assumption here. Yes, we are trying to maximize as well as optimize. Okay. So now we have 10 components, and each of the component is able to explain some amount of variation. Again, always remember, first component explains maximum variation, followed by second, third, and so on. एक order इनका यही maintained रहेगा, that first component will always explain highest amount of variation. Now, we have decided that we will reduce it into 10. The next question is, which variable will go into which component? So, scree plot is clear. Coming to the next table. Now, in order to decide that which variable will go into which component, there are two tables that are given here. One is called component matrix and the other is called rotated component matrix. Since we have gone in for rotation, actually rotation, Varimax rotation is optional. Some people don't go for rotation, but we as statisticians definitely prefer rotation. Why? Because as I said, factor analysis is a fundamental concept which is based on maximum rotation. And in order to attain maximum rotation, you have to go in, sorry, maximum variation. And in order to have maximum variation, you should go in for rotation. So that is why it is a scientific approach if you go for rotated. So if you are going for rotation, please ignore this component matrix table and go into the next one, which is rotated component. Okay, now you can see there are 10 components or 10 factors here, and there are 44 variables given here, those 44, which we have taken for the analysis. Now we have to decide that which variable goes into which component. Starting with the first one, that is talkative. Now please see this horizontally, okay? And for whichever component the value is highest, talkative will go into that component. Just see the value and ignore the sign. So can anybody tell me that talkative will go into which component? 0.658 factor 2. Very good. Please ignore the signs, just see the magnitude. So talkative goes into component 2. Can anybody tell me finds fault किसमें जाएगा? Finds fault goes into component 6. Very nice. Does a thorough job goes into component 1. Right. So this is how you are going to decide that which variable goes into which component. So how do we do this? Take a paper, write all the 10 components at the top, जैसे इसमें लिखा हुआ है, and after each component, जैसे 1 के नीचे आप उन variables का नाम लिखे जो जो उसमें आ रहे हैं. Then under 2, write all those variables which are coming in the second, then third, then fourth, and then so on. Now, if you remember, I did tell you that there was one option in the output section that was sort by size, if you remember. Let us do that and see how it changes your rotated component matrix. Okay. So let us rerun it and do it sorting by size. Go to analyze, dimension reduction, factor, outputs पर जाकर click on sort by size and click on OK. Now the software has rerun the factor analysis. Ignore all the tables क्योंकि बाकी सब में कोई फर्क नहीं पड़ेगा. Just come to the last and see rotated component. Now can anybody tell the difference? I would be happy if anybody of you can identify what difference has been made. जितने variables component 1 में जा रहे थे, all of them have come together. Disorganized, does a thorough job, lazy, careless, efficient, reliable, all of them have come together. And this is the beauty of factor analysis. अगर इन variables को हम देखें, so they are almost similar to each other. A person who is disorganized will obviously not be able to do a thorough job. वो lazy भी होगा, वो careless भी होगा, right? his efficiency will also be, I mean, don't see the sign. वो negative positive दोनों हो सकता है. Just try to see the trait. So this is the beauty of factor analysis. I hope you all are able to understand all the variables which are almost related to similar personality. They have come together in factor 1. Disorganized से लेके detractable तक, all these have come under factor 1. They have magnitude maximum. Second में आइए जरा. In the second factor, which variables are coming? Quiet, shy, reserved, talkative, outgoing, assertive. Now all of these are almost similar. A person who would be quiet would definitely be reserved, would definitely be shy, वो talkative नहीं होगा, outgoing नहीं होगा, assertive नहीं होगा. So on the basis of these variables which are coming into second factor, you can name it. इसको कुछ भी नाम दे सकते हैं आप. Reserve दे सकते हैं नाम, talkative दे सकते, मतलब so naming a factor is purely your choice, researcher's choice. So जितने variables एक साथ आ रहे हैं उनको हमने एक साथ नाम दे दिया. Are you all able to understand that how do we decide that which variable goes into which factor? I hope this is clear to all of you. The magnitude should be greater than 0.5. No, ऐसा बिल्कुल नहीं है, Dr. Vinay. Here it is not important that magnitude should be greater than 0.5. Here the only thing that is important is that it should be maximum. Like if you see for disorganized, the value should be maximum amongst all the components. Even if it is less than 0.5 chalega, but it should be maximum. Then it will go into that particular component. Okay. Any other doubts that anybody of you have? In the last table, it tells you the correlation between the components. This is not very important. Some people report it, some people don't report. So it's purely your choice. Shall we consider all related variables as one factor? Yes. All the variables which come into one factor, they are definitely in one component. The next would be in the next component and so on. So last table is the correlation between the components. The new components that have been made, it is the correlation between the two. I am speaking about related objects. I am not able to understand your question, Dr. Vinay. Okay, you can be unmuted. I think now all the participants could be unmuted so that we can have some time for questions. Those of you who cannot, write it on the chat box. Different factor have lower side, higher value. Its method show ranking. Okay. I think Dr. Yadav, if you are here, you can please unmute the participants so that some of them who have any questions they can ask. How does it contribute to our purpose? I mean, the last table, it does not contribute to your purpose, Ritvik, so you can just ignore it.
Participants, you can unmute yourself.
They
Hello.
have just given it.
Can you go to the
No need
previous
of,
table, madam?
interpreting the last
Where-
one. Yeah.
Madam,
Yes,
can you go to the
somebody is
previous
speaking.
table? Yeah, this is Dr. Vinay, madam. Can you go to the previous table where we have seen the factor one with 0.7 something?
This one?
Yeah.
Yeah.
Madam, here you said that the first one, disorganized and does a thorough job, lazy. Few things you stack it together and said that all these items are making sense. But
Yeah.
I'm not able to understand that because disorganized is completely different. Does a thorough
A
job
person who is
is
disorganized
exactly.
would
Hmm.
not be doing a thorough job. A person who
So
is
here negative and
disorganized,
positive values
sorry,
indicates here the negative value is indicating negative thing and does a thorough job where he
just
has points.
I already, just a second, Dr. Vinay, I already said that this does not mean the direction. It could be opposite. It is about the trait. A person who is disorganized would be not doing a thorough job. Means all these questions are somewhat focusing on one particular aspect of the personality. It's not important
Madam,
that the
yeah,
direction should be the same. That is why you can see
okay,
the signs are completely opposite. Disorganized is negative,
okay.
does a thorough job is positive, lazy again is negative. So sign itself is an indication
Madam,
that
so
the
up to
two things
distractible,
are,
all,
just a second, please
madam,
let me complete, Dr. Vinay.
yeah,
If the signs are different, it indicates that it is opposite to each other, but the trait is similar. A person
got
who
it.
will be disorganized would be lazy and not be doing a thorough job. Disorganized would not be related to shy. Okay. So shy, quiet, reserved, talkative, these things are one particular trait of a personality. Disorganized, lazy, careless, this is one particular trait of personality, which
Yeah,
is, this is what
madam,
it means when we say that underlying or hidden dimensions. Yes.
okay. Madam, up to what is that? Distractible. The values are
Yeah.
greater than 0.5. So can we
No, no,
think
no.
that
It's not about 0.5. No, it's not about 0.5. It's about
Mhm,
the value is maximum amongst all the components. Even if it is
okay.
more than 0.5, it hardly matters.
Mm-hmm.
Even if it is less than 0.5, it hardly makes any difference. It should be maximum for amongst all the components.
It should be maximum among all the components. Okay, got it.
Good evening, ma'am. Ma'am, in the
Yes.
previous table where you have displayed the eigenvalue, can you
Yeah.
please move on to that?
Yeah. This is the eigenvalue.
Yes, ma'am. In this table, you have the components, the first column, components. What
Hmm.
does the component means here, ma'am? Is that the
Component
43
means for
numbers?
all the 44 variables, it will make
Huh.
44 different components, factors.
Okay, ma'am. Then again in the table which is below, which you have said again components only, component 1 to 10. And you have again compared those 10 components from here to the 43 variable, or sorry, 44 variables again.
For these 10 components, so why did it decide on the 10 components? Because only 10 had eigenvalue more than 1. So now
Okay.
44 variables, you will be trying to reduce it into 10 components.
Okay, okay, ma'am. Okay. Just grouping them. Okay.
Ma'am, actually, I want ask one question. This actually, if we make the tool of 44 question, then we have after reducing this, we have only 10 question for the tool.
Yeah, what happens is that uh, now you know that these questions are similar to each other. मतलब अब हमको ये पता चल गया that disorganized, does a thorough job, lazy, all of them are almost similar to each other. Now
Okay.
what you can do, instead of putting all of them, जिसका भी यहाँ पे वैल्यू आपको लग रहा है that the
Maximum.
value is very less. I
Okay.
mean, don't see the sign, just see
Okay.
the value.
Yes.
If you feel that the value is very less as compared to other, you can remove it from the questionnaire. This is one approach. तो उससे क्या होगा? Your questionnaire would be like the dimension of the questionnaire would be reduced. That is one approach. Okay. Answer to your question. One.
Yes.
Second approach ये होता है that if you remember, I had also selected on save as variable option. Now, if you see the data set, in the data, now you all have not run it, but if you all will run it, then you will see that in the data, at the last, it has created factor 1, factor 2, factor 3. Like this, it has created 10 different variables.
Yes.
Now, since I had run it twice, हमने 2 बार रन किया था, तो मेरे में 20 बना दिए हैं उसमें. But when you will run it once, you will see it has created 10 different factors.
Okay.
Some people use these variables, like these observations, as new variables. मतलब अब वो 44 की जगह हम इन 10 variables को भी use करके we can go ahead with the analysis.
Okay.
After you have reduced the dimension, you will have 10 new variables. I mean 10 new components. This will be the value of these components, right? You will get this in the form of variable in your data. Some people, instead of using those 44, use these 10 newly
New variables.
created factors.
Okay.
तो एक approach ये हो सकता है, and one approach could be, if you want to stick to your questionnaire only, then seeing the results, seeing the rotated component, those variables which have very less value as compared to the others, they could be removed from your component. Okay?
Okay.
I hope the doubt is clear. It was a
Ma'am,
good question.
Yes, ma'am. And next is the second and third and fourth. It's a 10 component is there. And in the lower part, where the high is in second column is a 0.72. Second column has some finding more than 0.5 in second column, second factor में.
कौन सा factor? ये quiet वाला ना?
हाँ, ma'am,
से
quiet
it
is
going
point
up
in
to-
second factor 0.84
quiet से
and
लेके it is
785.
going up to reserve.
Okay.
Sorry, assertive.
Okay, ma'am. Actually, I am thinking that the second variable we have to take in on that part. It also show the questionnaire we have to set. The first questionnaire we have to set on the first factor and on the second and the third.
No.
Okay.
Sorted by size means that in the first, it has put all these in the first component. Then
Okay.
in the second component, अब this detractable तक तो सारे चले गए ना first में. So now
ma'am.
you go into the next one. So
Okay.
now quiet will go into the second. Why it will go into the second? Because amongst all these, maximum value is for the second component.
Okay.
Then reserved will again go into the second. So ऐसे करके हम decide करते हैं.
Thank you, ma'am. Thank you. Thanks a lot.
Ma'am, I have a question.
Mm-hmm.
So these 44 personalities are some type of traits that we have displayed here. So a component means is it like some sort of ulterior trait? Are we grouping them into a particular personality type for further research, or what are we doing here exactly?
You are trying to reduce the dimension. That is, you are trying to club these 44 traits into reduced set. That could be 10, 9, 8. You are trying to find out the hidden structure of the data.
So all these, for example, from disorganized to distractible, all these people have somewhat similar personality type is what we're meaning.
I would not say that people have. I would say that these variables are similar to each other.
How is lazy and efficient then similar, man? But doesn't make sense.
Lazy and efficient. A person who would be lazy would not be efficient.
Yes, ma'am.
Yeah. So it is the same trait, but reverse in the sign. I just now explained that it is one similar trait, but opposite to each other, as in, just see the signs. A person who would be lazy would not be efficient. But it is one similar trait of a personality.
So
Lazy would not be similar to quiet.
I understand that, ma'am, but what I meant was, are these 9, for example, from disorganized to distractible, are these 9 traits, for example, under one particular type of people, or what is the component here? Like,
Similar to each other, that is what we have found out.
ma'am, I'm not audible, ma'am.
These traits are similar to each other. That is what we have found out. We are trying to make groups out of these 44 variables or 44 traits. So basically, I've tried to find out that from disorganized to detractable, they come under one trait. So rather than taking all of them, you can remove those which have less value. There's no point in taking all of them together. So your basic objective is to reduce 44 into a lesser number of group. And reduce कैसे करेंगे? Only when we are able to make group within.
Okay,
So
so
this,
within the groups, the variability, there's high correlation, but between the groups, it's less correlation between the
yes,
components.
yes.
Okay, but what do we do after this, ma'am? Like after the fact analysis, what is the next
That's
step?
what I have just now explained this, that after this, either one way is that you remove those variables which have lesser value, so that instead of asking these 44 questions, you have a revised questionnaire which has more to the point like questions, and which sort of removes those variables which are not contributing much to finding out the personality. कैसे find out कर सकते हैं? जिनके लिए भी this value is lesser, like suppose from disorganized to detractable, all of them come under component 1. Generally from component 1 we try to not remove any variable, because most of the variables which come in the component 1 are explaining good amount of variation. So generally we do not remove that. But with the other components we try to remove the variables. So 44 se reduce, okay. Number one thing is this. The second way which we do after this is that rather than taking all the 44, there are, which I just now shown in the data, there are 10 new variables in the form of factors which are given on the data. So instead of taking those 44, you can simply go in for the 10 new variables. I think if you people must have studied regression in the previous class, you would have studied multicollinearity. Factor analysis is one beautiful way of dealing with multicollinearity. If you have many variables which are highly correlated with each other, so ye identify karna that which variable should be removed, how to reduce the multicollinearity, this is how we do it.
Yes, ma'am.
Madam, in 1 to 10 factors that are there, so we will select one item which is fitting the most, right? For example, for factor 1 here, disorganized, which is fitting most. And factor 2 will go and we'll look at something like quiet personality or something like that, right?
Why do you just want to select one? You should not.
But ultimately we want to stick on to 10 variables only, right, madam?
So those
We
10,
have
if
to
you
give names for the
10 questions.
10 questions.
You
Then
have to
we
give
have
the
to
names
choose
for the 10 components, but that name should depend on all the variables which come in that component, right?
which one is
Not
more
just
appropriate, which one
disorganized.
is more appropriate and meaning the same. That need to be
It
selected,
purely
right?
depends on your choice, whichever name you want to give. Not necessary the first component only.
Okay, got it.
Ma'am, I hope this is not a repetitive question. It's just a doubt I have. So in this, we have come to a conclusion that we have from 44 variables, we have reduced to 10. So from this, what is the interpretation I'm getting? Oh, sure, I got the interpretation that these are grouped together, but is this somewhere I can use anywhere in the study, same study, or it is like just a pilot study? I'm extracting the data, I'm extracting the questions from this data, and I'm going to apply in the next study like proper 10 questions. Is it like that, or?
Actually, pilot study is done for that study only. So you collect the data, then you perform factor analysis,
Okay.
then you try to reframe your questionnaire if you want to restructure
Huh.
your
As
questionnaire,
you said in
and
this
then
case
you
again,
can go ahead and complete the study.
but as you said in this case, if you have many variables like this, you have to recruit at least 10 times that population.
Yeah.
So it is quite big population. It is a quite big sample, 400.
Yes, absolutely correct. So that is
Huh.
why factor
Huh.
analysis is sometimes like it is difficult to do factor analysis for a pilot study. But
Okay.
factor analysis is definitely done to reduce multicollinearity.
Okay. Thank you.
Ma'am, can I ask a question, please?
Yes.
Ma'am, just to interpret, in factor 1, we have up till distractable, those elements which are having the maximum scores. So it is our decision after this whether to keep all of them or to delete some. Am I right?
Yes, if you want to sort of stick with your original questionnaire of 44 variables only, then
Yeah.
those of you, like those of variables which have less, it should not be that you remove disorganized because it is having the maximum magnitude. So please, I mean, it definitely depends on your choice, but please don't remove that variable which has the maximum magnitude. You should only be removing those variables which have lowest magnitude within that particular component.
Okay, ma'am. Which means that, for example, here in factor in 1, it would be distractable.
Yes.
Okay. Thank
Absolutely correct.
Madam,
madam.
is it a type of validity analysis? That means we
Yes.
are looking
Yes.
into the validity of the questionnaire.
Yes, it is also a type of validity. It is a validity analysis. It is to remove multicollinearity. It is to reduce the dimension. You can say it with all these
Okay,
forms.
got it.
Hello, madam.
Thank you.
Yes.
Is it we always use Varimax rotation?
No,
Prefer
it
the
depends on
Varimax.
the type of. It depends on the type of variable.
If so, for same data, if you use the Equimax rotation, then again the component will be the different.
No, but for ordinal scale, Varimax is the best.
Okay.
It depends on the scale. There are different ways. I think some has even asked that dichotomous and multiple choice. Yes, you can go for dichotomous and multiple choice, but the method of factor analysis becomes different then, and the rotation method also becomes different.
Yes, madam. But if you use Equimax, Quadrimax, or oblique rotation, then we get a different again the variables.
Yes. You will get
Yeah.
different because it depends on the scale. As I
Okay.
said that with different scales, we use different types of rotation and different types of methods to do factor analysis.
Okay, madam. And another question is, madam, can we use
Yeah,
ECA?
but for ordinal and for metric, for both these types, I think it is best to go in for, because generally we use either numeric or ordinal. So for numeric or ordinal, it is best that we go for Varimax rotation and we go for principal component method.
But principal component is used for numerical data, na? But if we use for the ordinal data,
I
then
have used for ordinal only, madam. It is correct. You can use it for ordinal also.
yeah, but then when we use correspondence analysis.
Sorry?
Correspondence analysis.
Correspondence analysis is different. Its objective is different. Multiple correspondence and principal component analysis are two different methods.
Okay.
Yeah.
Thank you, madam.
Ma'am, I have a scenario. I mean, it's a doubt. Supposedly, if I'm conducting a study on lifestyle of a certain set of people, And as you know, in lifestyle, there's many like health, there's also like, you know, various factors to lifestyle. So if I like before conducting the collecting the sample or the data, if I divide the questionnaire into certain parts of supposedly if my sleeping habits, you know, my physical activities, all those contribute to my lifestyle. So can we call that division as a factor, or is it something else totally?
You can call it as factor, but not on your own. Let let the system do it for you, like system or the software or the procedure that you are doing. You can't do it on your own.
Okay, okay. So the factors must contain similar questions, or
The factor, yes, the factor does contain similar, like
okay,
questions having similar objectives. Yes.
okay, okay, ma'am. Thank you, ma'am.
Okay, so if we have no other question, then I think we should end this session now. Thank you all so much.
Thank you so much, ma'am. It was very, very,
Dr.
very clear.
Thank you, Dr.
Thank
Swami,
you very
for
much,
Thank you, ma'am.
explaining.
Thank you
Wonderful
so much,
session.
ma'am.
Wonderful session. Wonderful
Thank you,
session.
ma'am. It was a wonderful session.
Really,
Thank
really
you.
wonderful.
Thank you.
बहुत अच्छा explain किया मैम. Thank you so much.
Thank you so much. Thank you all.
Thank you so much.